Hello, good morning everyone. Myself Supriya Mahato from Indian Institute of Engineering, Science and Technology, Sipur. Today I am presenting here a project done during my internship period in Emertxe Information Technology. Now let us see the project name, which is Washing Machine Simulator using PIC 16F877A MC. Then we see my presentation contents, table of contents, introduction, embedded system and its components, PIC microcontroller, software used, embedded C, peripheral description, project demonstration, sample outputs. Now, in the next slide, we can see here the introduction of washing machine. Washing machine have become an essential part of our daily lives, revolutionizing the way we wash our clothes. What was once time consuming and physically demanding work has now become easier thanks to these modern marvels of technology. From the early days of manual labor to today's smart devices that can practically wash clothes for us. Then, generally, a question arises, what is embedded system? An embedded system is a microprocessor or microcontroller based system designed to perform a dedicated function or set of functions within a larger system. Unlike general purpose computers, embedded systems are optimized for specific tasks, making them efficient and reliable. They consist of hardware, which is processors, memory, input or output devices, and software, often operating in real-time environments. Embedded systems are widely used in everyday devices such as home appliances, automobiles, industrial machines, and medical instruments, enabling automation control and communication functions. Then in this slide we can see here what are the different types of embedded system. At first, embedded system can be divided into two parts. First one is based on functionality and the second one is based on performance. Then further based on functionality divided into four different parts, which are real-time, standalone, network and mobile. Then we can see here based on performance it divides further into three parts: small scale, medium scale and sophisticated. Here we see the types of embedded system. Then in the next slide we can see the different components of embedded system. Here we can see the main components of an embedded system. At first we see here microcontroller or microprocessor acts as the brain of the system. Executing instructions and controlling other components. It controls the other components. Then memory. Memory is divided into two parts. First one is RAM and ROM. What is RAM? RAM, it is a temporary storage for data during operation. Then ROM, it stores the program code permanently. Input devices, sensor, switch or buttons used to collect data from the external environment. Output devices, LEDs, display, motor or other devices used to show results or perform actions. Communication interfaces. There are so many communication interfaces. Some of them ports. Some of the ports are like UART, SPI, I2C, or USB for data exchange with other systems. Then power supply. It is a very important component of the embedded system because without power supply nothing can be happen or proceed further. It provides the power supply provides the necessary voltage and current to operate the system. Then timers and counters. Or what are the usage of timers? It used for time related operations and event counting. Then analog to digital converter and digital to analog converter. These are used to real world interfacing. Then at the end, one more major component of embedded system we can see here, which is software. It program or code the control the hardware operation. Throughout the code we can control the hardware. Then in this slide we can see here PIC microcontroller. Here in my project, to build this project I use PIC16F877A microcontroller. Now generally a question arises, what are the features of PIC16F877A? Now let us see. You can see here the different features of PIC16F877A. It is a popular 8-bit microcontroller by Microchip featuring 14 kilobyte flash memory, 368 bytes RAM and 256 bytes EEPROM. It operates up to 20 MHz and has 33 input-output pins and 3 timers and 8 channel 10-bit analog to digital converter and supports UART, SPI and I2C communication with 2 PWM channels, a watchdog timer and operating voltage of 2 volt 5.5 to 5.5 volt. It is ideal for embedded applications requiring reliable, efficient and flexible control. That's why we here use PIC16F877A microcontroller in our project. Then here I list out what are the software used during my project implementation. Then here PIC, SimLab, MPLab, XIDE and XC9 compiler and obvious PIC16F877A MC board. Then we can see Embedded C. Embedded C, it is an extension of the C programming language used to develop software for embedded systems. It includes features that interact directly with hardware, such as accessing memory map, input-output devices, and handling interrupts. Embedded C is efficient, close to machine-level code, and widely supported by microcontroller vendors. It helps programmers write compact, fast, and reliable code for devices like microcontroller and embedded processors. Then we can see different peripheral descriptions. At first we can see LED. It stands for light emitting diode. It emits light when current flows through it in the forward direction. LED emits light when only forward direction current flow. Backward direction current flow, it doesn't emit light. And polarity sensitive has anode and cathode terminals. Works on the principle of electroluminescence used in displays, indicator, lighting, etc. It requires a current limiting resistor to prevent damage. It, uh, it is a low power consumption and long life and small size. Then we can see tactile switch as digital keypad. By, by hearing the name tactile switch, we can understand that it is a type of switch which is used in digital keypad. In microcontrollers, switches are often used as inputs to control the operation of the device or to interact with the user. When the button is pressed, the switches turn on, and when the button is released, the switches turn off. They are typically connected to specific input pins on the microcontroller, enabling the detection of switch state changes. Then we can see here CLCD. Generally, the question arises in mind that what is CLCD or what is the full form of CLCD? CLCD stands for Character Liquid Crystal Display. Then LCD, Liquid Crystal Display. It is a flat panel display technology that uses liquid crystal to modulate light and display images or text. LCDs operate by modulating light through liquid crystals controlled by electrical signals. Important pins for interfacing with an LCD liquid crystal display include power, which is VDD and VSS, control, which is RS, RW and E, and data line pins are, we all know that D0 to D7, along with the contrast control pin V0, VO, and backlight pins A and K. Then in this slide we can see interrupts. What is interrupts? Interrupts in microcontroller are hardware or software both signals that temporarily suspend the normal program execution to handle critical events or external stimuli. And internal or external recurs to the MPU to stop the processing, attends to the request. Two types, hardware and software. There are two types of interest, which are hardware and software. Then we can see timers. Timers in microcontrollers are versatile hardware modules used for measuring time intervals, generating precise timing signals, and implementing time critical operations. They can be configured to operate in various modes, including timer, counter, pulse width modulation, which is PWM, and capture or compare modes, catering to a wide range of timing requirements. Then, timers often feature adjustable prescalers and reload values, allowing for fine-grained control over the timing resolution and period essential for applications such as motor control, communication protocols, and real-time systems.
Now let us see the demonstration. Simply coding for the washing machine. We now upload the code in the board. This is simply PIC 16F877A MC board. Here we uploaded, and we can see in CLCD press key 5 to power on the washing machine. So whenever we press the switch 5, so it can show the washing programs. Now press. Here we can see by pressing it can shown in the board three options, then or more options. There are different options for this. Uh, we whatever option we want to select, simply we long press this option. Here we can see rise plus dry, dry only, wash only. There are so many options. So we select wash only. So long press there. Then we want to select auto. There are different levels of water, low, medium, high. We select low. By pressing long time we select the mode. Then we press switch 5 for start the washing machine. So I pressed switch 5 and it takes time, and then it starts washing the clothes. We can see here that fan is running, so the washing machine is wash the clothes. If we want to stop the machine, then we have to long press 6, so it stops. Now let us see by pressing 6 the machine stop. Let's see, the fan is stop, so washing machine is stop. If we want to again wash the clothes, then we have to press the switch 5. Let us see here that fan is again start running. In this way the washing machine is running or operating. In this way it operates and wash the clothes.
We see the operation of washing machine, and which is the final result of my project. Now the conclusion part. In the conclusion part, I want to say that the washing machine simulation using PIC Simulab served as an effective tool for learning and applying concepts in embedded systems. It offered a hands-on experience that complemented theoretical knowledge and provide a foundation for further exploration in the field of automation and control system. At the end of my presentation, I want to thank to the team Emertxe Information Technology. Thank you.